IBESS, Climate Change and Energy Production, Part 3, will focus on renewable energy sources. Hydroelectric energy, wind energy, photovoltaic energy, wave and tidal energy, biomass energy, and geothermal energy. The significant ideas are there is a range of different energy sources available to societies that vary in their sustainability, availability, cost, and socio-political implications. The choice of energy sources is controversial and complex. Energy security is an important factor in making energy choices. Here is the outline of all the available movies in the Climate Change and Energy Production unit. Use this outline to find the movie you need for review. This movie is focused here. Part 3, this movie, will examine renewable energy sources, while Part 2, the last movie, examined non-renewable energy sources. You need to be able to outline a range of energy sources, and here is the outline. This movie will focus on renewable energy resources, and that includes hydropower, solar voltaic, wind, biomass, wave and tidal power, as well as geothermal energy. Here are the IB syllabus statements that drive movies Part 2 and 3. Outline with description the range of energy resources available to society. There is a range of different energy sources available to societies that vary in their sustainability, availability, cost, and socio-political implications. In this graph of energy use over time, we can see the range of energy sources employed by people over this time period, and we can see the change in the relative use of these energy sources over time. The total quantity of biofuels, wood and dung, have changed very little over time, but the world's population has grown tremendously. The proportional share of biofuel energy in the world has decreased as the use of non-renewable fossil fuels has increased. In this graph, the renewable energy forms are hydro, seen here in light blue, and the biofuels in dark blue. Neither represent a large part of world use. This pie chart nicely shows renewable energy forms representing nearly 17% of the world market. Interestingly, among renewable energy forms of energy, biomass and hydro dominate. Biomass energy is the wood and dung used mostly by people in less economically developed countries to cook their food and heat their homes. The details in this graph are interesting, and you should spend some time studying this graph. Again, this graph displays world energy use over time by energy sector. And this graph includes biomass, hydro, and solar, wind, and geothermal energy as renewable energy sources. Clearly, these renewable energy forms represent a very small portion of world energy use relative to non-renewable fossil fuels, coal, oil, and natural gas. Notice the large increase in world use of energy since the 1950s. This represents an increasing population and increasing affluence worldwide. This graph displays per capita energy consumption from 1820 to 2000, and it reinforces the view that non-renewable energy sources, seen here in red, green, and purple, dominate societal choice, and that started in the late 19th century on. It's interesting to note that per capita consumption of biofuels, wood and dung primarily, decreased in the 20th century. Despite the continued use of biofuels worldwide, per capita use of renewable biomass energy has declined with the arrival of non-renewable fossil fuels and a growing population. In the U.S., renewable energy forms represent only 9% of the U.S. energy market, while hydro and solar and wind energy forms are present in this graph. The use of biomass is probably higher than you would have expected, given that the U.S. is an MEDC. But remember, biofuels include ethanol from fermented plants. Ethanol is now added to gasoline, thus increasing the U.S. use of biofuels as a renewable form of energy. I'll let you stop the movie and spend more time with this slide. This graph projects energy demand out to 2040 and beyond, and what's interesting is the predicted increase in what's noted here as sustainable new technology industries, with a proportional decrease in fossil fuel use. Now, generally, I agree with this graph, except that it includes nuclear energy within the sustainable category. Remember, nuclear energy is non-renewable in the same way that fossil fuels are non-renewable. But nuclear energy does not result in the release of carbon dioxide, so it's considered a more sustainable form of energy. This slide presents a rough estimate of energy source cost using U.S. prices as a guide. My interest here is to talk in relative terms, but keep in mind that energy cost influences whether or not a society uses the energy source. You can see that solar and wind energy are expensive, while coal and nuclear and hydro are less expensive. As soon as the cost of renewable energy sources comes down, their share of the market will increase. But the huge advantage of renewable energy forms is not their renewable nature, it's that they do not contribute to increasing levels of carbon dioxide in the atmosphere as coal or gas would. This slide displays an advertisement promoting the use of non-renewable fossil fuels as a cheaper source of energy. This advertisement was paid for by the Heritage Foundation, a very conservative group that's in bed with big energy companies in the U.S. As soon as the renewable energy forms can be subsidized or made cheaper for the average consumer, their share of the market will increase. With this table, you can see in green the relative share of renewable energy forms in MEDCs and LEDCs. Spend some time with this slide. Note the high percentage of biomass used in LEDCs. This represents the wood and dung burned for cooking food and heating homes. Here is a relevant IB syllabus statement. Sources of energy with lower carbon dioxide emissions than fossil fuels include renewable energy forms such as solar, biomass, hydropower, wind, wave, tidal, and geothermal. The use of renewable forms of energy is expected to increase. Here are the IB syllabus statements that drive this movie forward. Evaluate the advantages and disadvantages of different energy sources. There is a range of different energy sources available to societies that vary in their sustainability, availability, cost, and sociopolitical implications. Let's start by looking at hydroelectric energy, an energy source that comes from the hydrologic cycle, where water moves by gravity downhill. The force of water moving with gravity downhill is the energy harvested as hydroelectric energy. In this image, you can see the dam that holds back a river. As the water runs through or over the dam, turbines generate electricity, as can be seen with the electric lines in the distance. The hydrologic cycle involves the evaporation of water, the condensation of water, and the movement of water, clouds, and vapor, with water falling in uphill locations and flowing downhill back to the ocean. Hydroelectric energy is when humans harvest the energy from the flowing of water due to gravity. By building a dam here, water is then managed to run through a turbine to produce electricity. Hydropower requires a river and high technology to build the dam. As well, dams are expensive to build. Here is an image of the Hoover Dam built on the Colorado River in the United States. Water flows into these towers, falls, and spins copper wire within magnets, producing electricity. Hydropower is available to societies in biomes with rivers. Countries located strictly in deserts without rivers would be less likely to employ hydropower. You can see how it works here. Water flows downhill, spins a turbine, and produces electricity before the water is released downstream. The water flowing into the turbine and being released downstream is generally colder than what would be present without the dam, and the dam dramatically alters the flow of the river. The ecology of the river is changed by dams. In the upper left image, we can look over the Hoover Dam to see the magnitude of the drop. And in the upper right, we can see the turbines within the dam. And in the bottom, we can see the power lines that move the electricity to Las Vegas in Nevada. This early photograph of the Tuolumne River Valley in California was taken before a dam was built. The dam was built and it flooded the valley under a reservoir of water. Consider the ecological change. It's dramatic. Here is a painting of the same valley, the Tuolumne River Valley. Think about what was lost when people built a dam for hydropower. Here is a photo of the Hetch Hetchy Reservoir that flooded the Tuolumne River Valley. The reservoir covers the valley and changes the ecology of the river. The landscape remains beautiful in its own way, but we have to remember the sacrifice that comes with hydropower. The species in the river are different, as what exists is a lake, not a river, and downstream the temperature of the water has changed. The water behind the dam is deep and warm, while the water released from the dam below is cold and potentially intermittent. The ecology of the river is changed, the species change, the biological community changes. This is a photo of the Glen Canyon Dam, also on the Colorado River, like the Hoover Dam. You can see how the flow in the river is different as a result of the dam. But, to the advantage of people, the reservoir has multiple uses beyond just the production of energy. There's available irrigation water and recreation, just to name two advantages that come when a dam is built. But while the reservoir can be beautiful in its own way, and it can be used for recreation, the large surfaces of the reservoir result in more water being evaporated. In other words, less water available than might have been if the dam had never been built. And dams have a finite life because they ultimately fill in with silt carried downstream by the river and deposited by the slow-moving water at the dam. Here is another photo of a dam no longer in use because of silting. One last possible advantage of dams, other than to create power, is that they control flooding. You can see in this graph the variation in flow of the Colorado River before the building of the Hoover Dam and then after. Dams reduce the extremes of water flow year to year. Here is a table that compares the advantages and disadvantages of hydroelectric energy as a source of energy for societies. You can stop the movie now and study this slide on your own. Here is the outline of renewable energy sources. I've just covered hydropower, now on to solar voltaic. Solar voltaic energy is the energy produced when sunshine radiates on panels that produce electricity. The solar energy excites electrons on various compounds that results in an electrical current. The available energy radiating from the sun is highly abundant. Much like hydropower, solar voltaic power is limited regionally. Hydropower requires flow-in water, while solar voltaic power requires sunshine. But the available energy radiating from the sun is highly abundant, albeit regionally and seasonally variable. Despite the overall abundance of solar energy, the sun is not always shining locally. Think about nighttime. Thus, solar energy would need to be stored in a battery. Solar voltaic energy requires technology, and it can be expensive. And depending on the local need for power, Large areas are required for panels that would provide sufficient energy for reasonably large communities. And while costs are decreasing, solar panels remain an expensive energy source. But remember, one of the most important advantages of renewable energy forms like solar voltaic energy is the low carbon emissions, and it's a sustainable source of energy. Here's a table that compares the advantages and disadvantages of solar voltaic energy as a source of energy for societies. You can stop the movie now and study this slide on your own. Wind energy results from wind that spins a blade. A turbine is turned, creating electricity. The harnessing of wind energy requires large land areas, and it requires wind. As you can see in this image, even in areas that might have wind, wind is not always available. Wind power requires technology, and the technology is expensive. And wind turbines on land can be unsightly, but one could use the land around the turbines to farm. Wind turbines can be located over the ocean, where the wind is more likely to blow, and out on the ocean, the turbines are not easily seen. Again, a lot of land is required, but the land could serve multiple purposes. But when the blades are spinning, wind turbines are noisy. Would you want one near your home? And what about the relationships between the blades and birds? Here's a table that compares the advantages and disadvantages of wind energy as a source of energy for societies. You can stop the movie now and study this slide on your own. Here is the outline of renewable energy sources. I've covered hydro, solar voltaic, and wind. Now on to biomass and biofuel. Biofuels include wood, dung, and alcohol, or ethanol. The ethanol comes from fermented plants. The term biofuel is used because the energy in biofuels comes from photosynthesis, the uptake of carbon dioxide to produce energy-rich molecules used as biofuels, ethanol. The burning of wood, dung, or ethanol does release carbon dioxide, but wood, dung, and ethanol are carbon dioxide neutral because they originate from plants that have taken up the carbon dioxide equivalent during photosynthesis as they grow. The energy originates from living organisms, thus wood, dung, or ethanol are renewable energy resources. It's very important for you to understand why wood, dung, and ethanol fuels are renewable and not polluting. In other words, these fuels are carbon dioxide neutral. The carbon dioxide released when these fuels are burned would be absorbed by photosynthesis in plant growth, carbon neutral. But there are particulates that are not great for one's health if they're inhaled regularly. Can you explain why biomass energy, also known as biofuels, would be considered renewable? Can you explain why biomass energy is carbon neutral? Ethanol, used to power engines, comes from the fermentation of plants. Now that you understand why ethanol is considered carbon neutral, here's a more difficult question. What plants are we using to ferment to produce alcohol? Is it sugarcane? Were forests cut down to grow sugarcane? If so, ethanol may not be as carbon neutral as its proponents might argue. And one more thing. Is potential farmland for food crops being used to make fuel? If so, then those of us who demand fuel for our cars or our planes might be causing less food to be grown. We need to carefully consider the implications of using ethanol as a biofuel. Are forests being cut down to grow sugarcane? Are the economics of fuel changing how people manage land? Is the demand for fuel by the rich changing the available food supply for the poor? In this image, we can see an interesting system. Crops are grown to feed the cows, whose manure is fermented to produce methane, used to create electricity that would heat the building that provides shelter to the cows. The sludge left over from the fermentation of the manure is used to fertilize the crops. Biofuels in action. Here is a table that compares the advantages and disadvantages of biomass, or biofuels, as a source of energy for societies. You can stop the movie now and study this slide on your own. Here is the outline of renewable energy sources. I've covered hydro, solar voltaic, wind, and biomass. Now on to wave, tidal, and geothermal energy. It's going to be fast. We're almost done. Wave power is a huge source of potential energy, renewable energy, only for the countries with access to coastline. Technology is required to appropriately harness wave or tidal energy, and the technology is expensive. Here is a table that compares the advantages and disadvantages of wave energy as a source of energy for societies. You can stop the movie now and study this slide on your own. Tidal power is a huge source of potential energy, renewable energy, only for countries with access to coastline. Technology is required to appropriately harness wave or tidal power, and the technology is expensive. Here is a table that compares the advantages and disadvantages of tidal energy as a source of energy for societies. You can stop the movie now and study this slide on your own. Geothermal energy is the heat energy generated from within the Earth. The geothermal gradient, which is the difference in temperature between the core of the planet and its surface, drives a continuous conduction of thermal energy in the form of heat from the core to the surface. Societies such as Iceland have harnessed geothermal energy for heat. Geothermal energy is available in specific locations, not many locations. As well, there is the potential for dangerous gases, and the technology to move the hot water is expensive. Here is the table that compares the advantages and disadvantages of geothermal energy as a source of energy for societies. You can stop the movie now and study this slide on your own. And that brings us to the end of IBESS Climate Change and Energy Production, Part 3.